Hi, everybody. Welcome to semester 2. So we are going to, with what limited time we have, right? We only have 35 minutes. We're going to kind of segue into another piece of genetics and apply it to what we learned last week about Walter. And so just kind of to recap too, what we learned about Walter last week related to him having sickle cell, which was the result of a single base pair mutation. And so today we're going to kind of extend it a little bit and learn about pedigrees and what that means. And so today's goal with our shortened class period is to just finish Walter's pedigree, and I'll explain all about it when we dive in. So one of the key kind of questions, and you don't have to write this down, I'll let you know when you do so that way you can kind of get a little bit of practice. But the idea here is, or one of the essential questions is, how do we track all of our traits through generations? If our great-great-great-grandmother had something, and then we can track that particular trait, whether it's a disease or if it is a, hair color or eye color. We learned about different traits, and we can track them through families in a number of ways. And so the first one that I'm going to kind of introduce to you is the idea of a pedigree. So in your notebooks, I want you to flip to your Unit 3 vocab page. So this was right at the very beginning of our Unit 3. For me, it is right before entry 12. So right before entry 12, I have a vocab sheet, so I want you to add in a pedigree. And what that is a record or recorded ancestry of a person or a family, like a family tree. So if you need to pause, go ahead, take a second to write that down, and then play when you want to keep going. There's different symbols that we use to kind of denote males and females and how to kind of show a family line. So, for example, males traditionally are always going to be squares. So in the course of a family tree, brothers, dads, grandpas are always going to be squares. If they are deceased, then we oftentimes put a slash or an X through them just to say that, they were there obviously, but they are no longer living. Females are going to be circles. So mothers, grandmothers, great-great-grandmothers, sisters, daughters, all females are going to be circles. And again, if they are no longer living, they get a slash, or sometimes you might see it as an X. If we want to show some kind of couple or a, joining of two individuals, we put a line between them. So if two people are together, we put a line between them. They may have children, and I'll show you what that looks like in a little bit, but they don't necessarily have to. They're just going to be joined. And if they were together but are no longer, then we kind of show that as a broken line to signify a previous relationship, again, which may or may not have children associated with it. If we're trying to show a generation, we have kind of a downward line and then a branch point. So for example, I could have a mom and a dad, let's say they're still together. Between them, I would have this branch down, and that says that this couple up here has had 2 children. In this case, they've had a son on the left and a daughter on the right. And it doesn't matter the order of siblings. It's not necessarily like oldest on the left or anything like that. It just signifies how many children. So my little hypothetical drawing couple here has had 2 children. And then because this square and circle are off kind of the same branch point, I know that this boy and this girl are siblings because they came from the same set of parents. Sometimes there's twins, and so you kind of see this branch point like this, meaning that they kind of separated out. You would see a mom, a dad, and a mom, and then something like this to signify that those two are twins, whether identical or fraternal. So these are some of the things, or the kind of the key to decipher what a pedigree looks like. And so let me show you one put together. So here we have a couple of things going on. And the key point of this slide too is to understand that in addition to just setting up a family tree to kind of know how many generations and siblings and children people have, we can use it to track diseases or traits. In this case, I'm tracking a disease. And so anyone who is affected with the disease would be shaded in. Or it could be a trait that I'm looking at, like if I want to know the family history of freckles or dimples in my family, anyone who happens to have freckles or dimples, I would shade in. So it doesn't necessarily have to be a disease, but usually it is. So we can also see that in this case there is one generation that had children, so this is the second generation, and they had a set of children, the third generation, and then they had children, the fourth generation. So you can kind of see here we have 4 generations worth of individuals. We have our, starting individual couple here, and it looks like the dad or the man in this relationship had whatever trait we're looking at. And then they had 3 children, a daughter and 2 sons. And it looks like the daughter and one of the sons has whatever that they're tracking, and the other son did not. The daughter then went on to have 3 children of her own. You can kind of see that here. The middle son here had 2 boys. The rightmost son had 3 children, 2 daughters and a son. And then you can kind of see here other branch points going into the next generation. Some of them had 1 child, some of them had 2 children, and then some of them, for example, decided or haven't had children to date. So in this example, this boy that I'm circling in purple and this girl that I'm circling in purple does not have any children. Okay. And it's a little, to kind of jam it into, it's a little misleading because we don't necessarily see like for example, the union that led to this child. So there are kind of the partners that helped produce these children. They're just not included in this particular picture. But just kind of understanding that pedigrees can track families as well as diseases. So let's practice. We're going to, in class, utilize the chat to see if we can identify the different pieces in this particular pedigree. So I have a couple of them labeled A, B, C, D. So which one of these represents a male? And hopefully you are signifying C. C's or squares are males. Female would be A. Circles are females. A marriage or a union in some way would be B. And then D here, though not a question, is showing children. This particular couple had 1, 2, 3, 4 children between them. They had 2 girls and 2 boys. Okay. So a person who's expressing the trait. I'm going to change my color here. Let's say I'm going to make that one blue. Anyone who's expressing the trait is someone who is shaded in. So just kind of looking at my graph here, anybody who has been shaded in is expressing the trait. Anyone who is not shaded in would not be expressing the trait. So that's everybody who was kind of an open box or an open circle. They're not expressing the trait. So I'm just kind of color coding here to match with my key. A connection between parents and offspring. That would be D, like I mentioned before, or you could kind of really do any of these downward lines that I'm coloring in pink here. That dignifies that children have been had by parent and offspring. And then the last question, how many generations are we seeing here? I don't know, I'm going to make it orange. We can see 1, 2, 3 generations. So we can gather a ton of info just by looking at a pedigree. And so what we're going to do with a little bit of class time that we have is we're going to go back to Walter. So if there's any space left on the B page of entry 14, you're going to use that space. And if not, then you're going to go to the next fresh page. But really what's going to happen here is you are going to draw Walter's pedigree. If you remember last week, we had a slide that kind of went through his family members that did and did not seem to have the same symptoms as Walter, indicating that they may or may not also have sickle cell anemia, which is what Walter ended up having. So I pulled up that slide one more time and put it right here. So I'm going to end up pausing it and then having everybody in class try to create a pedigree. So what I'd like you to do right now, if you're watching this outside of class time, is to give it a pause and see if you can pull out the information. And in this case, I'm going to kind of delete these extra bits from last time that we don't need, and turn it all back to, well, I'll leave those there just in case, to reconstruct the family tree. And then in here, I did kind of put my own example notes here, and I kind of zoomed in. We don't know the names of any of his siblings or his parents or grandparents. We just know Walter. So I ended up kind of putting Walter in the middle, and I just kind of drew around him to fit onto my space. I knew that he had 3 sisters and 2 brothers, and his parents seemed to be fine, but his dad's brother did seem to have some symptoms, and his dad's mother, or his paternal grandmother, seemed to also have the condition. So this is kind of what I ended up with as a result. And if you want to write a key to kind of help you, circle equals female, square equals male, to help you remember how to draw a pedigree, please do so. All right. And that's pretty much it. That's really all that we're going to end up getting to in class. And so on Thursday, we're going to jump into, trying to understand a little bit more about the genetics, why chromosomes don't just, double every time a kid is had. And that's the goal. So in terms of any work needed to be done, just finishing up the pedigree on that 14B page. Or if you needed to go to a new page, that is more than okay for you to do. Thanks, everybody.